Okay, everyone, today we're going to continue our talk about inference for two-way tables. So the last thing that we talked about was a test for homogeneity for inference for two-way tables, but today we're going to talk about the chi-square test for association or independence. Sometimes it's called the chi-square test for association. Sometimes it's called the chi-square test for independence. Both are correct names, and I will talk to you about the difference. So let's start with a bigger question. We see a two-way table, and we want to know, is it a test for homogeneity, or is it a test for association, right? So here's how we know the difference. We've talked about homogeneity, where we say there's two or more populations. So there's two or more populations, and we're asking them one question. So for an example, I have a group of Canadians and a group of Americans, and I ask them, the question is, are you left-handed? Okay, so two distinct and separate populations that I've each randomly sampled, and I asked them one specific question, are you left-handed? So what we're trying to get at with a test for homogeneity is, are these two populations the same in regard to this one question? So for association or independence, I have one population, and I'm asking them two or more questions. What we're doing with a test for association or a test for independence is we're trying to see, in this one population, is there a connection or an association between these two variables that we're asking them? Right, so maybe I have a group of Canadians. So I have a group of Canadians, and I ask them two questions. The question is, are you left-handed? And the other question is, what color are your eyes? So what is your eye color? So I have one distinct population, Canadians, and I'm asking them two questions. Are you left-handed? And what is your eye color? Right? So I'm trying to see, is there an association or a connection between handedness and eye color? Okay, so homogeneity is for two or more populations where we ask them one question and we want to know, are those the populations the same? Association or independence is one population and we want to know, are these two variables connected or associated amongst this population? So those are really the differences. How is the chi-square done? Mechanically, they're identical. So we're going to do everything the same. The only difference is the way that we state things in the state. But mechanically, the way that we calculate the chi-square, the way that we do the plan, our expected counts, all of that is going to be identical. Now, just to be confusing, because, why wouldn't we be? Sometimes you see a two-way table, right? And it has one variable here, and we have another variable here, second variable here. Technically, for that one, I could do a two-sample z-test, right? For proportions, for like a difference in proportions. So this is really tricky to look at the difference between all three, and I think that's what makes this so hard. So know that when we do a chi-square, okay, whether it's homogeneity or whether it's independence, a chi-square is always two-sided. So if I'm asking something and I want to know something that's greater, is this proportion greater or is this proportion lesser than another? I'm looking at a two-way I'm looking at a two-way table that would be a two-sample z-test for proportions. So if I'm seeing keywords greater than or less than in a proportion, and I see a two-way table and it's just 2 by 2, that could be I would probably do a two-sample z-test for proportion there if I'm looking at greater or less than, because that's a chi-square won't do that. So really, that's the only time I need to look out for a two-sample z-test for proportions. If I see more than two of anything, it's going to be a chi-square every single time, right? And if it's two-sided, we can do a chi-square. Why is Ms. Shobe taking the time to do this? You generally lose a point if you misidentify the type of test. A point out of 4 points. So that tends to be a lot, but it's not the end of the world if you mislabel it. So that's why I'm taking some time to kind of explain the two. So today we're going to focus on association or independence. So let's look at an example of something you might see for this. So again, we're looking at what is the relationship, what is the association, what is the connection between two categorical variables. So you might ask a question like this: are people who are prone to sudden anger more likely to develop heart disease? An observational study followed a random sample of 8,474 people with normal blood pressure for about 4 years. Okay, and then they took a trait anger test. Researchers also conducted a test for coronary heart disease. So this is the anger level, low, moderate, or high, and we have our CHD, our coronary heart disease. Did they have it? Did they not have it? And we have all of our totals, and there's our graph, and things are really pretty. And then we're asked this question: does this data provide convincing evidence of an association between the variables in the larger population? So anytime I see does this data provide convincing evidence, that's my code word for I'm doing a test. And when I see the word association, I'm going to call this a chi-square test for association. So you could call it a chi-square test for independence, but I choose to name it based on what they ask me in the problem. So sometimes they'll say, are these two variables independent of each other? Then I would call it a chi-square test for independence. This one specifically says, does this data provide convincing evidence of an association or a connection between the two variables? So I'm going to call this a chi-square test for an association. So this is an example of something you will see for a chi-square test for association. All right, so let's talk about how we would state the hypotheses. So if it's a chi-square test for association, and I name it as a chi-square test for association, I'm going to use the words association. So I'm going to say my null is there is no association between anger levels and heart disease status in the population of people with normal blood pressure. And my alternate is there is an association between anger levels and heart disease status in the population of people with normal blood pressure. Now the alternative to this is looking at independence. So if we name it independence, the wording is slightly different, right? So if I call it a chi-square test of independence, I write my state in terms of whether or not something is independent. So before my null said there's no association, that means there's no connection, no link between these two. They're completely, the word is, independent, right? So for the null for this one, I would say anger and heart disease status are independent in the population of people with normal blood pressure. And then the alternate is anger and heart disease are not independent in the population for people with more blood pressure. So if you'll notice, for the association here, I used the word no, and then I said there is an association, but here I use the word independent, and then I use the word not, right? So those are complete opposites, but think about what they mean. No association means there's no connection between them. That means they're independent. Hey, look at that. An association means that there's a connection. Knowing one thing about one tells me something about the other. That, by definition, is not independent. So both of these ways to state this are correct. Truly, how do I choose? I default to what the question said. All right, so then we need to do our plan. Expected counts, just to refresh, is row total times column total divided by table total. So why don't you just do, why don't you get out your calculators and let's just do a couple right now. Let's do this one and this one, right? Just to check and make sure you know how to do this. So let's do less low and no moderate. Okay, so take a second, get out your calculators. You're going to do row total times column total divided by table total. All right, so I'll slowly work these. I'll color coordinate them so you can see the difference. All right, so for the blue, it's this times this divided by this. For the purple, it's this times this divided by this. Okay, so just want you to try two. Okay, show it to your neighbor friend. Make sure she has the same thing. Okay, by now you've used your calculator. You've tried just those two. That's all I'm asking, just two. Okay, and then let's take a look at the expected counts. So for low and yes, we had 69.73. For moderate and no, we had 7,624.92. Notice they left 2 decimals. I would always leave at least 2 decimals. I like to leave 3. Whatever the book left 2, I'm not going to judge. 1 is usually not enough. So, is there a rule? No, but you're going to be a little bit more accurate with 2 or more. So I tend to stick to 2 decimal places. Let's try an example. A random sample of 40 students completed a survey stating whether or not they had allergies on the Census at School website. Here's a two-way table with their data. So again, they were asked 2 questions. So we had a distinct population of, because I haven't had you go on the Census at School website, but essentially what they do is anyone can enter and they ask you a series of questions. So we're talking about one population, several questions. So here's a two-way table with their data. Female, male, allergies, no allergies. Do the conditional probabilities suggest that allergies and gender, and again I put that in quotes because that's how the census phrases sex, show an association. So calculate the appropriate conditional probabilities and then make a graph that compares the conditional distributions. Describe the relationships between the 2 variables suggested by the data. Okay, let's get into this. Okay, so here's the table, and you could have done this either way. I just did amongst females and amongst males as my condition. You could have done it amongst allergies. It just makes sense to me to look at it like this and like this. So that's what I chose to do. In this case, because they didn't say show me conditional distribution of allergies, or they weren't very specific. We could go either way, but I'm going to do this way. So I'm going to look at females first because ladies first. And let's see. So I'm going to go 10 divided by 23. And that is 0.435 have allergies. And then I'm going to go 13 divided by 23. and I get 0.565, did not have allergies. Okay, let's look at males. Okay, so for males, I would have gone 8 out of 17, and I would have gotten 0.435 had allergies. And then 9 out of 17 equals 0.539 did not. Okay, so those are my conditional probabilities there, right? And then I would graph it. And because these total 100%, and so do these, oh my goodness, I'm going to do a segmented bar graph to explain this. So that's what I did. So I did a segmented bar graph, and I'm looking at this, and I have allergies and I have no allergies. So looking at this, it says, does this provide some sort of evidence that there is some sort of association between the two? And looking at this, I might be like, well, you're more likely to have allergies if you're male, but it's not, there isn't much of a difference. And that's probably what I would have stated at this. The proportion of males who have allergies is slightly higher than females, suggesting that there might be a relationship between what they call gender and allergies on the survey. However, we're not entirely sure. We would need to do a test for that. So that would be question 2 then. Does this data provide convincing evidence of an association between gender and having allergies for U.S. high school students who filled out the Census at School survey? So that's what I want you to do. And we're going to do this like you would on the AP Stats exam. I'm going to give you probably for a question like this, which is fairly straightforward. I know you're going to laugh, but it's fairly straightforward. You would have about 12 minutes to complete this question. So I'm going to give you, you can time yourselves anywhere between like maybe 13 minutes to work on this question, and I want you to work on it on your own. After 13 minutes, your teacher's going to call time, and then I want you to share it with your neighbor friend. And then I will post the answers on the OneNote so that you can look at that. When you're done with checking your answers and talking to your neighbor friend about your answers and checking it all away, then you can go ahead and begin on your homework. Bye.